Everyone, so today we are going to have a go at experiment 9b.1 for Edexcel. It's the measuring current and potential difference in circuits experiment, where we are comparing the current and potential difference when you put more bulbs in parallel and in series. So what I've got with me is a battery holder or a cell holder with 2 cells in it to make up our 3 volts battery. I've got 3 lamps, 2 multimeters. They are just different colours, they do exactly the same thing, and then a load of wires. So first off, we need to make our first circuit. So here we have circuit 1. It is our 1 bulb in series. So starting at our battery, it goes round to our ammeter. So this multimeter is set up as a ammeter. You can see it's set to the 10 amp reading and plugged into the 10 amp plug and COM. It then follows round to our bulb. Then carrying on from our bulb, it goes back round to our battery. Our voltmeter is connected in series, so this black multimeter is our voltmeter, and you can see it is connected and pointing to the 20 volts. So for our first circuit, our voltage or potential difference is 2.59. and our current is 0.18. So our second circuit has 2 bulbs in series. So the wire I have added to make this circuit is the red one here. The colours of the wires make no difference, so that doesn't affect anything. It's just so you can see which ones I've added. So it goes from the battery again round to our bulb, round to our second bulb, then again round to our ammeter, then back round to the battery. The voltmeter is still connected in parallel across just 1 bulb. So here for our second circuit, the potential difference is 1.38 and the current is 0.13. So our final series circuit has 3 bulbs in series. So I've added in an extra red wire. So we're going from our battery to bulb number 1. You can see it is on just very dimly. Then we go round to bulb number 2. Then round to our third bulb, which was our original one. Then round to our ammeter and then back round to the battery. Again, our voltmeter is just in parallel with the first bulb that we had. Our potential difference is 0.93 and our current is 0.11. So for our fourth circuit, what I've done here is taken our original circuit, I've taken it all the way back to circuit 1, but then instead of unplugging any of our wires from our battery, I've actually just connected our second bulb in parallel with these 2 red wires. So instead, we've got our 1 big loop plus our second loop, and then we've got our voltmeter in parallel still. So our current is being measured for the entire of the circuit, not just in one of the branches. This is quite important to ensure you get the correct results. So our potential difference for this circuit, our fourth one, is 2.48, and our current is 0.36. So our final circuit is 3 bulbs in parallel. What I've done here is I have connected our third bulb to our second one with 2 red wires. So here's our first one, and then our second one is a bit long, sorry, but it does flow from one to the next. So again, we've got 3 different branches now. Our potential difference is being measured just across the one bulb, and then our current is measuring through the large circuit, not just inside one of the branches. So here for our last circuit, our 3 bulbs in parallel, our potential difference is 2.17 and our current is 0.51. Okay, so next we need to fill in the rest of our table. So our third column is saying the total current, which is this first column over here, multiplied by the number of lamps. So this first row, we only have 1 lamp, so our total current multiplied by 1 is just going to be 0.18. The second row that we've got here has 2 lamps. See here, it's got our 2 lamps, so we've got to multiply our 0.13 by 2, which is 0.26. And then finally, our third row, we've got 3 lamps in series, so we've got to do 0.11 multiplied by 3. Okay, then our fourth column. This time we are multiplying potential difference, multiplying by, again, the number of lamps. So this first row, we only have 1 lamp. Our potential difference is this column here. So we're going to just do 2.59 multiplied by 1. So that's still 2.59. Our second row is our 2 lamps, so we're going to do 1.38 multiplied by 2 to give us 2.76. And then our third row is our 3 lamps, so we're going to do 0.93 multiplied by 3, which is 2.79. Okay, then our very last column in our table has our total current divided by the number of lamps, and this is for a different set of rows. So our first one is still just 1 lamp, so total current divided by 1 is still going to be 0.18. Then this row that we've got next, we have 2 lamps in parallel. Might be able to zoom this out a bit more so you can see it a bit better. Yes. Okay, so we've got 2 lamps in parallel. So we're going to do our current here, 0.36, divided by 2, which gives us again 0.18. Then finally, this last row, we have 3 bulbs. So we're going to do 0.51 divided by 3, which is 0.17. So now we have filled in our table, we need to have a think about the questions underneath. So, question 2 says, what happened to the total current as more lamps were added in series? So, first off, we need to look at which of these results are from series circuits, and that is the first 3 rows. So I'm just going to highlight those. So it's our 0.18, our 0.13, and our 0.11. And what we can see here is that as we increased the number of lamps going down the table, our current decreased. So we can say it decreased. Then, what happened to the potential difference across one lamp as the number of lamps was increased? Still for a series circuit, so we're still only looking at these first 3 rows. So that is our 2.59, our 1.38, and our 0.93. And again, you can see as we go down the table, it decreases. So you can say again, it decreased. Now question 4 and 5 is when things start to get a little bit more interesting. It says, describe any pattern you see between the number of lamps and the total current in the circuit. So if we have a look at our total current and the number of lamps, what we should see is that if we multiply the current by the number of lamps, these values should all be the same. And you can see actually that isn't the case. So I'm going to write what you should see, but we can easily see here that that isn't the case. So I'm going to put no pattern should be total current times the number of lamps is a constant. Okay, so that's what we should see, but unfortunately our results don't show that this time. And then pattern for the number of lamps and the potential difference. Here we have got some better results. So if we look here, it goes 2.59, 2.76, 2.79. Yes, it does appear to be going up, but actually these values are all very close to each other, and that is what we should see. They should actually all be identical. So again, I'm going to put down here that the total, or not total, sorry, there is no total. So the potential difference, because it's just across the one lamp, so potential difference multiplied by the number of lamps equals a constant. Okay, next we are back to looking just at the basic results that we took. So this time we're looking at parallel circuits, which is our last 2 results, and also we're going to be comparing them to our very first one. So what happened to the total current as more lamps were added in parallel? So if we go back up to the top, this time we are looking at this one here, and then our 0.36 and our 0.51. So these 3, you can see actually the current goes up. So we're going to say here it increased. Then, for what happened to the potential difference across one lamp as the number of lamps was increased, we're going to look at our second column. Again, we are looking at this first one here, so I'm just going to highlight the end. Then we're looking at the 2.48 and the 2.17. So here you can see it does again look like it's decreasing, but if you compare that to our first 3 where it decreased, the decrease isn't very much. What we should see is that it stayed the same. So what I'm going to write here is it should stay constant. In other words, the same. Okay, next we're looking at the pattern. So pattern between the number of lamps and the total current. So this time we're looking at our final column over here, and this actually, we've got some really good results here. So we've got 0.18, 0.18 and 0.17. You can see actually when we do the total current divided by the number of lamps, it is actually constant, and these results are actually perfect. This is what we should be seeing. Obviously this last one isn't quite the same, but that will be due to rounding as well. So we're going to write here. So the pattern that we see is the total current divided by the number of lamps is equal to a constant. And then the potential difference, we've actually already answered this above. I'm going to just put C question 7 because we have already spotted that pattern. We could write it stays constant, but we don't need to write it out again. Okay, last part of this sheet then is our evaluation section. So 10A talks about why we see some of these slightly different values to what. So sorry, the camera cut me off, but this last question on our sheet is our evaluation question. So it says the lamps are often slightly different. If there was no clear pattern in your results, it might be due to differences between the lamps. Was there a clear pattern in what happened? So if we look at our results, as we said before, there is a clear pattern, but it could be clearer. It's not perfect. Our results for our total current multiplied by number of lamps is definitely not identical, even though it should be. And even our potential difference multiplied by the number of lamps isn't exactly the same. This final column we did pretty well with, but the other two, it's not perfect. So what I've written here is that there is a pattern, but it could be clearer. And so then for part B, it says, what does this tell you about how similar or different the lamps were? What it tells us is that they were fairly similar. They were pretty close to being identical, but they weren't actually identical. So that's what I've written for this final question. So I hope this video has been helpful for you all. As I said, this isn't a core practical, so you won't be tested specifically on this practical. You will be expected to understand the concepts behind it, specifically that if you have a series circuit with identical lamps, your total current multiplied by the number of lamps should be constant, and your potential difference multiplied by the number of lamps should be constant. Then in a parallel circuit, your total current divided by the number of lamps, where your lamps are identical, should be constant. So I hope this has been helpful to you all, and I will see you in the next video.